And lesson 51 is going to be on exponential growth and decay. So when we go to do either exponential growth or decay, this is the formula that we're going to use here. Also, this would be similar to using, A is equal to P e to the RT. They're the same formula. They're just different letters on them. So this formula, the A of T here would be your value after a certain amount of time. A sub 0 would be what you start with. E is just the value of E. K is going to be your growth or decay rate. You're going to write it as a decimal. So, for instance, if it's 5%, you would write 0.05. If K is positive, you're going to have growth. If K is negative, you're going to have decay. And T is the amount of time. All right, so let's run through some problems here. Colony of bacteria grows according to the law of uninhibited growth. Okay, so that means that when we have K, we should have a positive number, which if you look at the formula here, we do, according to that function, where N is measured in grams and T is measured in days. Determine the initial amount of bacteria. Okay, well, so initial amount would just be this number right here. So therefore that'd be 90. Growth rate of the bacteria would be this one right here, so 0.05 as a decimal. So if we write that as a percentage, that'd be 5%. Population after 5 days. So that would be N of 5, excuse me. So you're going to plug in 5 for your T. So you'll have 90 e to the 0.05 times 5, just to make sure that you know how to plug that in the calculator. So 90, your E button here is right above ln, and assuming you probably know that at this point. 0.05 times 5. So we get 115.56. So because we're doing this in the original problem, so that N is measured here in grams, we can go ahead and make that a decimal. And I'm just going to round one decimal place, so I'm going to say 115.6. If we were like measuring the number of people or things or something that would be tangible that you have to count, then you would round that up to the nearest whole number. So just be cognizant of what's being asked there and the type of answer that you should give if the directions don't specifically tell you. How long will it take for the population to reach 100 grams? So that means future value is 100, present value is 90. We still have 0.05, but now we don't know what T is. So to solve for T, you need to get the exponential part by itself. So I'm going to divide both sides by 90. You can reduce that to 10/9 if you want to, or just leave it. It doesn't really matter. Since we're going to be putting this into the, I guess I shouldn't put an equal sign there. Since we're going to be putting it into the calculator anyway. Now remember the trick, when you want to, what you're solving for is in the exponent, you're going to do a logarithm. And I'm going to do log base E. In this case, I'm going to use ln just because I have the E there. You can use base 10 if you want to. It'll still, in the long run, work out to be the same thing. That should be 90, not 900, sorry. So you'll have that, which then allows you to bring that to the front, and ln E is just equal to 1. So then you're going to have ln 100 over 90 equals 0.05 T. Then divide both sides by 0.05. So in your calculator, you'd put in natural log 100 divided by 90. Make sure you close the parentheses. Divided by 0.05. So approximately 2.1 days. Okay, how long will it take for the population to double? So for it to double, that means you'd have 180 instead of 100. So this will be exactly the same, except at this part right here, you're going to have 180 instead of 100. So you're going to have ln of 2. So for For that one, if I just change that to ln, either type in 180 divided by 90 or just 2, because 180 divided by 90 is 2, divided by 0.05. So it would take about 13.9 days in order for that to double. All right. There's all the answers there. Okay. Half-life. So when something deteriorates by a half-life, that means that when it tells you how long the half-life is, the amount goes down by half in that amount of time. Excuse me. So if you have 64 grams of a substance and the half-life of it is 10 days, that means you'd start off with 64. 10 days later, you'd have half of that, which would be 32. 10 more days, you'd have half of that. 10 more days, you'd have half of that, so on. So essentially, you're dividing by 2 each time. And because you're dividing by 2, technically, you're never going to get to 0. You're going to get a really, really, really small number, but because you're dividing by 2, a number divided by 2 is never going to give you 0. So technically, you're not going to get 0, but essentially, at some point, it becomes practically 0. The problem is, what if what you're given isn't the so when we did this one here, it went 10, 20, 30, 40, and so on, because those are, in multiples of 10 days there. But, what if I ask you something in between, like in this problem where I ask you for 34 days? So here's how this one's going to work here. So your half-life rate is always going to be the natural log of 0.5 divided by the half-life time. So for this particular problem, because the half-life is 10, my half-life rate would end up being natural log of 1/2. You can either write 1/2 or 0.5, doesn't matter which one. I'm going to write 0.5 because I think it's a little easier. Divided by the amount of time, which in this case is 10. Make sure you're doing the half-life time, not what the question is asking. All right, so in this case it would be 10. All right, so for 34 days then, so my A of 34 would be, I'm starting off, the original problem told you in the page before that you started off with 64. My rate is natural log of 1/2 divided by 10. You can plug that in the calculator, but you're going to plug it in the calculator, and then you're going to plug it in again for the formula. Why not just plug it in one time? And then I'm going to take that and multiply that by 34. Now, it's important that this 10 is not part of this logarithm. It's natural log of 1/2 or 0.5, whole thing divided by 10. All right, so then in this I can just take and plug it into the calculator. So, skip that over. Oops, didn't want to do that. All right, 64 times e to the natural log 0.5, close the parenthesis on that, divided by 10 times 34. Okay, and so if we round to the nearest tenth, you got about 6.1. So after 34 days, you'd have approximately 6.1 grams left over. All right, so that is lesson 51. Let me know if you have any questions.